Welcome back guys with a brand new video, and today we are diving into the world of signal processing and specifically exploring the Butterworth low pass filter with noise. In the previous videos we already discussed about the Butterworth high pass filter 10 pole specifically and Butterworth low pass filter 10 pole specifically. So in this video, we will explore the Butterworth low pass filter with noise. And but before we get started, if you are new here, do not forget to hit that subscribe button and ring the bell to stay updated with our latest content. And if you need assistance in your electrical and electronics and audio processing and signal engineering projects, then you can ping me a message on my WhatsApp number that is given in the description of this video, and also you can visit the Fiverr and Upwork profile. So what exactly is a Butterworth low pass filter? In signal processing, a Butterworth filter is a type of filter that allows signals, you can say, below a certain cutoff frequency to pass through while attenuating signals above the frequencies. It's known for its maximally flat frequency response within the passband, meaning it introduces minimal distortion to the passing frequencies. And you can say that the Butterworth filter is used at a very vast rate and commonly in various applications, from audio processing to image processing, and it's specifically especially useful when a smooth frequency response is crucial. And now let's introduce the noise in this. Noise is you can you all of you know that is an unwanted disturbance that can corrupt or interfere with the signals. In real world scenarios, signals are often contaminated with noise, which can affect the quality of information we are trying to process. So here, combining the Butterworth low-pass filter with noisy signals can be extremely beneficial. By applying the Butterworth filter to a signal affected by noise, we can effectively reduce the noise and extract the essential information within the desired frequency range. And so, if you see here, you have at a place of the input signal, we replaced let me also show you about the Butterworth low pass and high pass filter. Give me a moment. Here it is. As you can see here we have a signal inputs, and but when we are talking about or combining with it noise, then here we are using a noise. And so here we are getting the audio outputs, and I will also give me a moment to increase the simulation speeds and to decrease the current speeds to check out that how it's working. You can now listen the output. And here down you can check out the frequency range of the signals, and the maximum audio outputs we are getting here is the between is you can say varying between 1 volt to above 2 volt almost approximately. And it's working the working principle is similar to the low pass Butterworth filters, as and the combinations is seems first we are using an inductors and then a capacitors and then second inductor and then second capacitor and then third inductor and then third capacitors. And similarly with the specific values of the inductors and capacitors, and we are getting the outputs signals without a noise. And before we wrap up, here are a few tips and applications where the Butterworth low pass filter with noise reductions can be handy. And there you have it. We have covered the basics of Butterworth low pass filters and how it can be powerful tool in handling noise signals. I hope you find this video helpful. If you have any questions or want to see more content like this, drop a comment down below. Don't forget to give this video a thumbs up if you enjoyed it. Thanks for watching, and I'll see you in the next one.